Good evening, dear students. Yes, so in the last class, we had started with the chapter amines, right? So we were solving the MCQs based on the chapter amines. So what are amines, right? What are amines? So it is an organic compound which contains nitrogen, right? They are called as nitrogen containing compounds. Okay, they are termed as what? They are termed as amines, right? So so the students who have like not seen the amines, okay, in detail, we have discussed about the amines in our ACE classes, okay. So there you can see the detailed explanation, okay. So there we have already covered, okay, so we have covered what are amines, okay, so different types of amines, okay, types of amines. Then we have discussed the preparations of amine, physical properties, chemical properties, okay. So amines, okay, so how they behave, so that all we have discussed. Then about the diazonium salts, right, preparations, methods of preparation, properties, so everything we have discussed, okay. So let us continue with the questions, okay. I think we have solved some 14 questions, so this was a question which we did not solve, right, 13th question. So yes, so let us start. So here, so there is a sequence of reaction given. Okay, here a sequence of reaction is given. So you can see in the arrow marks. Okay. Okay, sorry. So yes. So here, okay. So let us continue. So here a sequence of reaction is given. Okay, and you can see on the arrow mark, they have given the, okay, so P. So we have to find what is P, what is Q, what is R. So they are given the final product. Okay. So they have asked, so set of reaction is given. So P, when it is reacted in the presence of Br2 and tin HCl, you get Q. Then Q, when you do NaNO2, okay, when you react it with NaNO2 in the presence of HCl at 272 to 278 Kelvin, okay, followed by this in the presence of orthophosphoric acid H2PO2 and water, okay, you get R. Further reacted with KMNO4, okay, in the basic medium, you get the compound, final compound, right? So here, so you have to find what is the starting compound P, okay. So how we are going to solve this? Yes, how we are going to solve this? So was last product, okay. It is a bromo substituted benzoic acid, right? You can see a bromo substituted benzoic acid. So what is Br2 in the presence of tin HCl? Okay, Br2 in the presence of tin HCl. Br2 means they have done bromination. Okay, when you take bromine, they are doing bromination. Okay, in the presence of tin HCl, why it is used? For reduction, right? Tin HCl is used for reduction. Then NaNO2 in the presence of HCl. When we use this NaNO2 in the presence of HCl for diazotization, right? When we have to do diazotization on aniline, right? So our starting product is having one as aniline, okay. Sorry, one as aniline, no. So startingly here what we have, we are reducing it, okay. So our Q, our Q will be having aniline. Okay, we are having Q as a aniline. Now here, what we are doing? Again, bromination also. So bromine will be substituted. Already there is a amine group. So it is substituted by what? It is substituted by Br. Okay. And you can see here carboxylic acid is there, right? Carboxylic acid. So KMNO4 is used for what? It is used for oxidation. Okay, it is used for oxidation. So here also there will be one reactant. Okay, because you can see at this position what you can see that there is a carboxylic acid. So with respect to your uh, aniline, okay, at the para position, there is one more group. Okay, so let us analyze it. So we have to go reverse. Okay, let us go reverse now. Here, what you can see here, a last product, okay, a bromo substituted benzoic acid here, right? So what they have done here, so before this, they have treated it with KMNO4 in the presence of OH. Okay, KMNO4, it is used as a oxidizing agent. So our R should be, okay, so your bromine will not get converted, okay, there it is not getting converted with KMNO4, okay, it will be like this only. So what you will get, so this will be your Br itself, and what, okay, from something, okay, it has converted to carboxylic acid, okay, group. So here it will be CH3. If it is a methyl group, okay, all the your two hydrogens, okay, it is two hydrogen, is oxidation means what? Addition of oxygen. So from this, what you are going to get, if I take a methyl group, I'm going to get what? I'm going to get COOH. So two hydrogens are replaced by OH, OO. Okay, oxygen. So my R should be this. My R should be this. Then before this, okay. So this before this, what they have done, they have treated it with NaNO2. Okay, it is treated with NaNO2 in the presence of HCl. Okay, so if I take my starting product as CH3, so I have got this also. Okay, so if I take this compound, okay, so what is the name of this compound? So, so this is our Q. This is our Q. Okay, this is our Q because it is having NH2. Okay, so what we have done, so CH3 we got. So when you have CH3, okay, so what we have done, so this is our Q. Then after that, before that, we have treated it with bromine and in the presence of tin HCl. So our compound will be a nitro group here. Okay, we are having a nitro substituted, okay, para nitro toluene. Okay, para nitro toluene. If we take para nitro toluene, so let us see now. So if we take a para nitro toluene, okay, so this is our nitro group. Here we have para toluene, and here we have a para nitro toluene. Okay, so if we take a para nitro toluene, so okay, if we treat it with tin HCl, okay, if we treat it with tin HCl, we are going to get NH2, okay, because it is getting reduced, and this is CH3. What is there? Br2. So bromination. So with respect to your methyl group, you are going to get a ortho substituted. So your Q will be this. Okay, your Q will be this. Further, what I am doing? Further, it is treated with NaNO2 in the presence of HCl. Okay, at 0 to 5 degrees Celsius. This is the first, followed by H2O in the presence of H3PO2. Okay, what I am going to get? What I am going to get? Your NH2 group. Okay, your NH2 group, what it will get? It will get diazotized. How it is going to get diazotized here? So it will be CH3Br. This will be N2Cl, N2 plus Cl minus. So this will get removed. Okay, this will be removed. So this will be like this. So this is our what? This is our R. Further treated with KMNO4, okay, in alkaline. So your CH3 will be converted into carboxylic acid. So this is our final product. Got it? Is it clear? Okay. So you have to follow the steps. So you have to understand what are the roles of this reagent. Br2, why it is used for bromination. Tin HCl is a good reducing agent. Okay, so we have seen whenever you have NO2, if you use tin HCl, it is easily you can get a NH2 group, right? So tin HCl is a reducing agent. Then NaNO2 in the presence of HCl, it is a good it is a diazotization. Okay, we are doing diazotization on aniline. So what will happen to aniline group? It will escape as N2Cl. Okay, so your this what N2 gas will be liberated, right? So it will get N2 plus and Cl minus. So your N2 gas will be liberated. Nitrogen will be escaped out. So you're going to get this group will be what escape. So it will be disappeared. Then KMNO4 is a good oxidizing agent. Okay, alkaline KMNO4. So your CH3 group is converted into a carboxylic group. So our answer is what? Para nitrotoluene. So option number C. Option number C. Para nitrotoluene. Okay. Is it clear? Okay. Fine. So let us go for the next one. 14th we have seen. 15th. Okay. 15th. So in the following sequence of reaction, again, A is there. Okay, in the following sequence of reaction, A is there. So A is done on A, we are doing reduction. On A, what we are doing? On A, we are doing reduction. Okay, on A, we are doing reduction. Then we are going to get B. Further, we are treating it with HNO2. Okay, to get what? To get a ethanol. So they have asked what is a compound A. Okay, what is a compound A? Now here again, so when you are doing such reactions, okay, you have to understand the role of the reagents. Reduction. For reduction, what we are going to use? Tin HCl. Okay. So okay, so this is a best reducing agent. So we can use here tin HCl. Now, so if you want to do reduction, so in our starting compound, what should be present? In our starting compound, what will be present? So here, HNO2. What is the role of this HNO2? When NaNO2, okay, when NaNO2, your sodium nitrate reacts with HCl, okay, NaNO2 reacts with HCl. What is generated? Nitrous acid. This is called as nitrous acid. So this is used for diazotization. Okay, this is used for diazotization. Okay, so here in your B, okay, there should be a aniline group. Aniline group because aniline, okay, only diazotization can be done on the amines, right? On the amines. So NH2. So containing NH2. So here in your B, NH2 should be present. So NH2 and you are going to get CH3, CH2. Okay, NH3. So this two will be same. Only what your NH2. Okay, if you do nitrous acid. So what will happen when you treat it with nitrous acid? You are going to get your ethanol. Okay. So yes. So this is your B. Now before this, okay, now here what should be your A? So options are propyl, propane nitrile. This is propane nitrile, then ethane. Okay, ethane nitrile, nitro, methane, and methyl isocyanide. Okay. So if I take a propane nitrile, okay, propane nitrile means what? CH3, CH2, and CN. Okay, when you have a CN group, okay, again one CN will be needed, but already we have two CN. C. Okay, So already we have here two carbon atoms. So already we have two carbon atoms. So when you have a nitrile group, when you have a nitrile group, okay. So already, so if you have this, so again one carbon will be generated. Okay. So if we take here as a ethane, okay, if we take a ethane nitrile, that is CH3CN, okay, so your CN group will be converted into CH2. So this will be what? CH3CN, ethane nitrile. Okay, option number C. Option number C. So here, okay, what all things we have to remember? So what is the role? Reduction, we can use tin HCl. Okay. So now whenever you have a nitrile group, okay, CN. So I'll write the steps from starting. So if I have CH3CN, okay, CN means a nitrile group. Okay, so that is cyanide, C triple bond N. Okay, so if you do reduction, so reduction, I'm going to use tin HCl. So what I'm going to get? I'm going to get CH3, okay, CH2. So what will happen? Hydrogen. Now what will be added here? Your hydrogen will be added. Just a second, I'll show you with another color. Okay, so across this triple bond, okay, across this triple bond, you can see your hydrogen will be added, your hydrogen will be added. So what I'm going to get? CH3, CH2, and H2. Okay, got it? So I'm going to get, so across, what is reduction? Addition of hydrogen. Addition of hydrogen. So your hydrogen will be added on carbon and your hydrogen will be added on carbon after removing this two double bonds. Okay. So I'm going to get CH3, CH2, NH2 for the treatment with nitrous acid. Okay. Nitrous acid. Okay. What we are going to do on aniline. So what I'm going to get? CH3, CH2, N2 plus and Cl minus. So what I'm going to get? Oh, I'm going to get CH3, CH2, OH. Okay. So your N2 Cl will be escaped out. I'm going to get a ethanol. So our compound will be ethane nitride. Option number C. My compound will be option number C. Okay. Next question here. An organic compound A on reduction gives compound B, which on reaction with trichloromethane and caustic potash forms C. The compound C on catalytic reduction gives N-methyl benzenamide. Okay. So the compound A is, so they have asked the compound A. So an organic compound. So they have asked what is compound A. So what is happening? I'll write the set of reaction, what they've asked. A compound A is there. We are doing reduction on that. You will get compound B. This compound B, which on reaction with trichloromethane. Okay. When you react it with trichloromethane. What is trichloromethane? Trichloromethane. Okay, chloroform and caustic soda. Okay, and caustic potash. Sorry, caustic potash. So that is your potassium hydroxide. You are going to get C. So this C on catalytic reduction. Okay, we are going to do what? Catalytic reduction. Catalytic reduction means what? With the suppose hydrogen in the presence of palladium, platinum, nickel. Okay, so that is called as catalytic reduction. Reduction means hydrogen addition of hydrogen. I'm going to get what? I'm going to get N-methyl benzenamide. Okay, N-methyl benzenamide. So how is the N-methyl and benzenamide? So this is a benzene, okay, amine, okay, NH and CH3. So this is a N-methyl benzenamide. Okay, benzene amine, N-methyl benzenamide. Got it? So they have asked what is A. What is A? Now, if I take, so the options are A, nitrobenzene, B, methenamine, C, nitromethane, and D, benzenamine. Okay. So what all are the steps. So here on A is reduced. Okay. So N-methylamine, before that, what I'm going to do, before that, after doing catalytic, this, I'm going to get the N-methyl benzonamide. So our A, okay. So if I take A as nitrobenzene, so let us see if I take A as nitrobenzene. So if I do reduction, what I'm going to get, students? Nitro, this nitro group. Okay, nitro group. If I do reduction, I'm going to get aniline, right? NH2. Nitro group is reduced to aniline. Oxygen is removed and hydrogen is added. Okay, so this will be my B. Further, I'm treating it with what? Trichloromethane. Okay, I'm treating it with trichloromethane in the presence of caustic potash. Okay, so what I'm going to get? I'm going to get here. I'm going to get a isocyanide. I'm going to get a isocyanide. Okay, I'm going to get what? Isocyanide. When you do, when you react it with potash, okay, caustic potash and chloroform, I am going to get isocyanide. This isocyanide, when you do a catalytic reduction, okay, catalytic reduction means addition of hydrogen. So here two hydrogen, here two hydrogen. What I am going to get? NH2CH3. Okay, NH2CH3. So this is the what? This is your, so answer is option number A, nitrobenzene. So if I take the organic compound, starting compound as nitrobenzene, so on reduction, we know that nitro group is reduced to aniline, that is NH2 group. This, when you treat it with your chloroform in the presence of caustic potash, will give you C. Okay, that is your isocyanide. So this is the isocyanide. Isocyanide means what? Your nitrogen is attached. Okay, your nitrogen is attached. Okay, so your nitrogen is donating the electron. So isocyanide. So this is when you do catalytic reduction. What is the catalytic reduction? What we can use? We can use hydrogen in the presence of platinum, palladium, nickel. Okay, to give you N-methyl benzenamide. So yes, so option number A is the answer. Okay. So next question. Gabriel thalamide synthesis is used in the preparation of primary amines from thalamide. Which of the following reagent is not used during the process? A, NaOH, B, HCl, C, KOH, and D, alkyl halides. Gabriel thalamide synthesis is used in the preparation of primary amines from thalamide. Which of the following reagent is not used during the process? Yes, Gabriel thalamide synthesis. Okay. What we use? What is the starting reactant? What we take? Okay, Bhuvan has answered as A. Okay, it is not used. Okay, NaOH is saying NaOH is not used. Do you know, remember the Gabriel thalamide synthesis? Anybody? Very important. Okay, for your this board exams. For your board exams, Gabriel thalamide synthesis is very important. Gabriel thalamide synthesis. So what is the starting product we are using? Which is the starting product which we are using? Yes, students, which is the starting product? Already we have discussed this Gabriel thalamide synthesis. We are using thalamide, right? We are using thalamide. So how is the reaction? We take thalamide, okay? This is the thalamide, right? This is our thalamide. This thalamide, we are treating it with what? Alcoholic KOH, okay? And what we are going to get when you treat it with alcoholic KOH? I'm going to get a what? Potassium thalamide, right? I'm going to get a potassium thalamide. So this is a potassium thalamide, right? I'm going to get a potassium thalamide. This potassium thalamide, I am doing what? I'm going to react it with the alkyl halide. I'm going to take any alkyl halide. So alkyl halides are also used. They have asked which reagent is not used. Okay. Alcoholic KOH is used. So we are going to react it with alkyl halides. So what I'm going to get now, I'm going to get a N-alkyl thalamide, right? I'm going to get a N-alkyl thalamide, right? So like this, N-alkyl thalamide. N-alkyl thalamide. This N-alkyl thalamide, further what I am going to do? I am going to react it with what? I am going to react it with NaOH, right? I'm going to react it with NaOH. What I'm going to get here? If I'm taking here alcoholic KOH, I should take here KOH only. Okay, I have to take KOH only. If I am taking NaOH, then I have to take NaOH. So if I treat it again with your KOH, so what I'm going to get aqueous KOH, here I'm going to get aqueous, here I'm going to use aqueous alcoholic. Now what I'm going to get? So here, okay, so this is the product. Okay, I'm going to get what? Phthalic acid. So one is our phthalic acid. I'm going to get phthalic acid plus primary amine, right? Primary amine. So what is not used? HCl. HCl is not used. Okay, HCl is not used to prepare the amines from thalamide. Okay, in the Gabriel thalamide synthesis. So if you are using here alcoholic KOH, here we are going to use aqueous KOH. If you are using here alcoholic NaOH, I'm going to use here aqueous NaOH. Okay, so any of this is used. Okay, so option number B. So NaOH used, KOH is used, alkyl halides are also used, but HCl is never used. Okay, so option number B is the correct answer. Okay, let us go for the next one. The correct order of increasing basic nature for the bases, okay, ammonia, methylamine, dimethylamine in the aqueous solution. So you have to tell the correct increasing basic nature. So how the basic nature will increase? How the basic nature? So one is your amine, NH3, another is your methylamine, then another is your dimethylamine. Another is your dimethylamine. So how you are going to give the basic nature, how you are going to give the order for basic nature, increasing basic nature for the bases. Yes. So what is the role of this methyl groups? What are the methyl groups? What they are called as methyl groups? Is it an electron donating group or withdrawing group? Yes. They are the electron donating group, right? The electron donating group. So because of the presence of electron donating group on the nitrogen, okay, so what they will do, they will donate the electron to the nitrogen here, right? So what will happen? The basicity will increase. Okay, so as you say in secondary, okay, so these are the secondary amines, these are primary amines. Okay, so here what you can see in secondary amines, two methyl groups are there. Two methyl groups, more what donating power. So in, electron as a electron donating groups are more. So what will happen? The basic character will increase. So plus I, right? So this will show plus I effect because electron donating group. Methyl groups are electron donating group. So secondary are greater than your primary and then, but they have asked the increasing order. So increasing means first your NH3. NH3 is the least basic. Okay, least basic. NH3 is least basic. Then your methylamine. Okay, and then is your dimethylamine. So dimethylamine is the what? it is having the basic character is more. Okay. So this is the order of basic character in the your substituted compounds. Okay. So option number D. Option number D. Okay. So because the methyl groups has a electron donating group, so in secondary secondary amines, number of methyl groups are 2. So what will happen? Plus I effect will be more. So secondary methylamines are more basic in nature than primary, and then your ammonia. Okay. So yes, option number D is the answer. Next question. The reaction of benzene diazonium chloride with aniline yields yellow dye. The name of the yellow dye is what? A reaction with benzene diazonium chloride. What is benzene diazonium chloride? N2Cl. So this is your benzene diazonium chloride. So this, when it reacts with aniline, okay, when it reacts with your aniline, you are going to get a yellow dye. So how you are going to get a yellow dye? This is the, okay, so this is the yellow dye. What I'm, so N double bond N. So this is the compound, first compound, N2Cl. Okay. Then to this will attach. Okay. So this will attach to this, and you are going to get what? Here NH2. Okay. So this is what? Para-amino azobenzene. Para-amino azobenzene. So like this, when group will be there, it is called as azo group. So para-amino azobenzene. Para-amino azobenzene. Option number B. Okay. The reaction of benzene diazonium chloride with aniline, it will yield you a yellow color dye. Okay. Yellow dye. This is called as what? It is called as para-amino azobenzene. Okay. Got it? Okay. Let us go for the next one. Which of the following is more basic than aniline? Which of the following is more basic than aniline, students? A, diphenyl. A, diphenylamine. Okay, it is amine. Then B, triphenylamine. C, paranitroaniline. And D, benzylamine. Which is more basic? I'll give the structures. Diphenylamine. Okay, diphenyl. Diphenyl means two benzene rings are there. So this is a diphenylamine. Okay, this is a diphenylamine. Okay, then triphenyl. Triphenyl means all the hydrogen atoms are replaced by your phenyl groups. So this is a triphenyl. All the hydrogen atoms, okay, are replaced by the phenyl groups. So this is a triphenyl. So this is option number A. This is option number B. Then para-nitroaniline. Para-nitroaniline. So this is our aniline parent compound. And at para position with respect to your aniline, you have nitro group. So this is a para-nitroaniline. Next is benzyl amine. Benzyl amine is CH2 is benzyl group and amine. So this is benzyl amine. Okay. So can you tell me which is C and this is D? Okay. So which of the following is more basic than aniline? Okay. Bhuvan has answered as D. Sri Varuni has also answered as D. Why? What is the reason? Why D? Why D? Why benzylamines are more basic than aniline? Aniline is what? Aniline is this. NH2. Why you are saying benzylamines are more basic than anilines? What is the reason? What will be the reason here? Electron with withdrawing group CH. Bhuvan has answered as electron withdrawing group is CH. Okay, so when we see option number A, okay, So what you can see, what will happen? The electrons from the nitrogen, they'll be delocalized, okay? But they will be delocalized where? Only in the ring, right? They will be, the electrons will be delocalized in the both the rings. So this is a what we can see by the structure. Second one, what you can see here, the electrons, okay, they will delocalize in how many rings? Three rings, okay, it will be delocalized in this three rings, okay, so electrons will delocalize in the three rings. Then here, which we see here, what will happen here? Nitro group. What is the role of a nitro group? Nitro is a electron withdrawing group, right? Nitro is a electron withdrawing group. So what it will do, it will tend to pull the electron towards itself. So it will pull the electron, okay. So that is due to minus I effect and also by minus R. So what it will do, your nitro group, as it is an electron withdrawing group, so it will withdraw the electron towards itself. Now here, in your benzylamine, what is happening in benzylamine? There is no any benzene ring again, right? Your NH group is not directly attached to benzene ring, right? So these electrons are freely available. Okay, these electrons are freely available for donating, right? Because the nitrogen is not directly attached to the benzene ring. So because of that, this is a more basic than aniline, because there is no nitrogen is not directly attached to the benzene. So it will not undergo conjugation. Electron delocalization does not take place. So these electrons are freely available for donating. Okay. So this is a reason why, yes, Sri Varuni has answered it very well. Electrons are easily available. Very good. Okay, so in benzylamine, you can see nitrogen is not directly attached to benzene. Okay, so hence it won't go conjugation and electrons are freely available for donation. Okay, so option number B is the answer. I hope you have understood. Next question. Which of the following will be the most stable diazonium salt? Which stable? So methyl, N2 plus X minus, then benzene, N2 plus X minus, then CH3, CH2, N2 plus X minus, then CH2, N2 plus X minus. So which of the following is the most stable? Yes, N2 plus and X minus. Option number A, B, C, and D. Which is the most stable diazonium salt? Option number B. Yes, very good. So option number B. So out of the given, okay, four options, your this diazonium salt, okay, benzene diazonium salt, BDC, benzene diazonium chloride. Okay, benzene diazonium chloride. It is what? It is a resonance stabilized. It is resonance stabilized and it is the most stable. So option number B is the correct answer. Okay. So out of the given diazonium salt, your BDC, benzene diazonium chlorides are more stable. Okay. So option number B is the answer. Fine. Next question. Okay. Which of the following is least soluble in water at 298 Kelvin? Which of the following is least soluble in water at 298 Kelvin? Methyl amine, trimethylamine, dimethylamine, or aniline? Which is least soluble? Yes. Which of the following is least soluble? Remember that aromatic amines, okay, they are insoluble in water. Why? Because of hydrocarbon, because the larger hydrocarbon part which will tend to retard the formation of hydrogen bond. So whenever you have aromatic compound as compared to the aliphatic amines, your aromatic compounds, they are least soluble in water. So option number D is the answer. Okay, option number D. Remember that. Next question. Which of the following has the lowest boiling point? Which of the following has the lowest boiling point? These are the options. Which of the following has the lowest boiling point? Which will have the lowest boiling point? Option number B, ether. Okay. So this is a formic acid. This is what? This is a formic acid. This is the alcohol. This is the amine. And this is a ether. So you can see there is what? You can see your OH group is there, electron donating, this is there, okay, electronegative atom is there. So in other options, they will form hydrogen bonding, okay, they'll form hydrogen bonding. But in ether, when you see RO R dash linkage, what you can see, there is an absence of hydrogen bonding. So because of absence of hydrogen bonding, it will have the lowest boiling point. Yes, option number B, okay, fine. So next question. So a set of reaction is given. Nitrobenzene is there. Okay, nitrobenzene. It is reacted with Br2 in the presence of FeBr3 to give you P. Further treated with tin in the presence of concentrated HCl to give you Q. Further done diazotization. Okay, in the warm water to give you R. So they have asked what is the R. Okay, so let us see nitrobenzene. So let us see the reactions. Okay, nitrobenzene, we are treating it with what? Br2 in the presence of FeBr3. Okay, what I'm going to get? So what we are going to do? We are going to do bromination. Okay, bromination. So meta position. At meta position, your Br will get attached. So this is our P. Further, we are going to do reduction in the presence of tin HCl. Okay, what we are going to do? Our nitro group. Okay, it will be converted into aniline. Okay, it will be converted into aniline. Sorry, NH2. Okay, it will be converted into NH2. So I'm going to get metabromoaniline. What I'm going to get? Metabromoaniline. Further, we are treating it with what? So this is our Q, PQ. Further, I'm going to do diazotization. Okay, in the presence of warm water. Okay, what I'm going to get? Here I'm going to get what? N2Cl. N2 plus Cl minus. Okay, and Br. So your what with in the presence of NaNO2. Okay, in the presence of NaNO2, I'm going to get what? I'm going to get a N2 plus Cl minus. Then I'm going to treat it with water, warm water. Okay, warm water. What will happen? Your N2Cl will be replaced by OH. Okay, so OH and Br. So this is my R. This is my R. Got it? So option number, which is the option number? OH. Okay, option number A. Option number A. With respect to OH, this is at para position. Sorry, meta position. Right. So option number A. Got it? Is it clear? So what all things we have done? We have a nitrobenzene. Okay, we did bromination. So at meta position, we got a bromo group. Then we did reduction. So we know that whenever we have nitro group, if you do reduction, you get a NH2. This NH2 further, what we are doing when you do diazotization, you are going to get N2 plus Cl minus, followed by treating with warm water, your N2Cl will be disappeared and OH group will attach them. Okay, so you are going to get option number A. Okay. What is Hinsberg's reagent? Very important. What is Hinsberg reagent? Hinsberg reagent. Hinsberg. Very important. Okay. You have to remember what is Hinsberg reagent. It is benzene sulfonyl chloride. Benzene. Remember? Benzene sulfonyl chloride. Okay. Benzene sulfonyl chloride is what? Hinsberg reagent. What is Hinsberg reagent? Benzene sulfonyl chloride. Okay. So option number A. Fine. Next question. So you have a benzyl chloride. Okay. You have a benzyl chloride. I am going to react it with aniline to give you A. A is reacted with methyl chloride to give you B. They have asked what is B. Follow the reaction. Benzyl chloride, when you react it with NH3, your Cl, okay, your this what Cl will be replaced by NH2. Your Cl will be replaced by NH2. Okay, NH2. So here what you are going to get NH2 and plus HCl will be product. So this Cl and one H will get HCl. So this is the A. This further reacted with methyl chloride. Methyl chloride. What you are going to get? Methyl chloride. When you react it with methyl chloride, both the hydrogens will be replaced by methyl groups. Okay, both the hydrogens will be replaced by methyl group. So I have got this. So what is the answer? What is the answer? NN dimethyl phenyl methanamine. Okay, so option number A. NN dimethyl phenyl methanamine. Okay. NN dimethyl phenyl methanamine. So option number A is the answer. So benzyl chloride treated with NH3 to give you what? Benzylamine. Okay, benzylamine. Then what you are going to get? You treat it with methyl chloride. So both the hydrogens are replaced by methyl groups. So you get NN dimethyl phenyl methanamine. Okay. The method by which aniline cannot be prepared is. So by which method aniline cannot be prepared? By which method aniline cannot be prepared? We know that with Gabriel thalamide synthesis. Okay, whenever we have Gabriel thalamide synthesis, we cannot prepare. Right. So potassium salt of thalamide treated with chlorobenzene followed by hydrolysis with aqueous. No. Only with Gabriel thalamide reaction, we can prepare primary amines. Okay, primary aliphatic amines, not aromatic. We can prepare only primary amines, that too aliphatic amine. So we cannot prepare aniline. Aniline is an aromatic amine. Right. We cannot prepare aniline with the help of Gabriel thalamide synthesis. So you can see potassium salt of thalamide treated with chlorobenzene followed by hydrolysis with aqueous NaOH. No, we cannot prepare. So option number D is the answer. Okay. Fine. Okay. In carbalamine test for primary amines, the resulting fall smelling product is, you get a very bad smell. So why you get that smell? What is the reason? The fall smell is due to what? It is due to the formation of isocyanides. Okay, because of isocyanides. That is CH3NC. Okay, isocyanides. When you get isocyanides, okay, in the carbalamine test, the final product is isocyanide. So because of this isocyanates, you are going to get that very bad smell. Okay. So this reaction. Okay. So this is the false smelling product is isocyanate, CH3NC. Your nitrogen will be attached. Okay. Attaching atom is nitrogen. When you have CN, it is cyanide. Okay. NC is isocyanate. Next question. A secondary amine is, what is a secondary amine? What is a secondary amine? Nitrogen containing two R groups, right? So this is a secondary amine. So your two R groups are present. A compound with NH2 group on the carbon atom in number 2 position. A compound with two of the hydrogen of NH3 have been replaced by organic groups. So yes, option number B. Okay, an organic compound with two NH2. No, two carbon atoms. Okay, a compound with two carbon atoms and an NH2 group. So option number B. Yes, Sri Varuni has answered. Okay, so this is the answer. So here in how is the carbalamine test? Let me explain you carbalamine test also. You have amines, okay, amines, how you are reacting in the presence of chloroform, CHCl3, okay, and KOH, potash, this caustic potash. Okay, what you are going to get? I am going to get isocyanates, KCl plus water. So this is a carbalamine test. Okay, this is a carbalamine test. So it gives you a very bad smell, very foul smell. Foul smell means very bad smell. Okay, so this is carbalamine test. Is it clear? So your option number B is the answer. Fine, got it? So these were some of the questions on the chapter amines. Okay, so this completes your chapter amines. Any doubts? So very easy, very scoring topic, amines it is. Okay. So very important name reactions are there. All the name reactions are very important. Okay. You have to practice those name reactions for your uh, this what for your board exams also. Those name reactions are very important. Okay. And for your common entrance test also, for your CET also, in the form of applied question. Okay, they will ask you. They'll not ask you directly, but they'll ask you reagent. Okay, they may give you the what is the product form like that. Fine. Any doubts up to that? Okay. So I think I have left with one more chapter, that is chemical kinetics. Okay. So in the next class, first let us complete. Okay, then we can give the mock test. Okay. So one more chapter is left. Okay, chemical kinetics. So in the next week, I'm going to start with the chemical kinetics. Okay, so last it is left. Fine. Any doubts in today's session? Okay. I hope there are no doubts. Okay, so let me end the session here. So we will meet in the next week. Yes. Thank you.